Today we are talking about disk fragmentation and backups. First, let's go over what disk fragmentation is. When computer files are created or deleted, the free space on the computer is split up into small non-contiguous blocks. This means that when new files are created, they, unfortunately, cannot be stored next to each other on the disk. Instead, they are scattered along the disk, fitting into any of the free blocks they find. This causes the file to become fragmented. Having fragmented files on your computer is not a good thing. It can cause the computer to run slower and it increases the risk of having corrupt files. But by using the disk fragmenter application, you can easily fix the problem of having fragmented files. To do this, the disk fragmenter rewrites the fragmented files so that they all fall into contiguous blocks next to each other on the disk. Step 1. In the diagram given, you can see that there are 5 files that have been saved to the disk: ITGS, English, TOK, Science, and Geography. Each file is saved in a separate sector. 2 of the files, ITGS and TOK, have more than one sector. This is because their files are too large to put into one sector. Due to the fact that they were the first files on the disk, they were put in contiguous sectors, which means they were right after each other. And as you can see, the last sector on the disk was remained free. In the second step, English and Science are deleted. This leaves the third, the sixth, and the last sector open. In the third diagram, a new file, art, has been saved. Following the rules of the file system, the new file's data goes straight into the first available free space. This would be right after ITGS. But this new file needs 3 sectors, and the gap is only 1 sector, so 2 more free sectors need to be found elsewhere in the disk. The next free sector is after TOK, but that is only 1 sector, so even more space is required. Another free sector is at the end of the disk, and this is where the final sector of art is stored. The problem now is that art is split into 3 fragments in non-contiguous blocks. This makes reading art from disk slower, because the disk read head must move to multiple locations to access the file. With a large number of files, disk fragmentation can cause serious performance problems. The diagram below is only an illustration. In reality, disk sectors are usually 4 kilobytes, so there will be thousands of sectors on a high-capacity disk. Likewise, most files will use many more sectors than illustrated here. On a frequently used hard disk, where data is often saved, deleted, and embedded, files can be divided into dozens or even hundreds of fragments, drastically reducing disk performance. By defragmenting a hard disk which has data on it, programs can run faster. This is because the files that were once scattered all over the hard disks have now been rearranged and packed close to each other, so that the hard disk does not have to go over every sector to start an application. This is an example of a disk defragmenter. DiskKeeper is one of the most popular defraggers on the market. The red in the drive map at the top shows all of the fragmented files. After defragmenting, the new drive map was pasted on the bottom for comparison. DiskKeeper can be set up to defrag the disk whenever the machine is idle. As soon as the user clicks the mouse or presses a key, the defragging is suspended. Backing up is a way of storing somebody's work and making sure that they have a second copy in case anything happens to their computer. There are 2 types of backing up, a full backup and an incremental backup. In this diagram, it is shown that there are many ways to back up data. There are many types of resources for backing up, and some are very small, but some are very large. These medias are as follows. An external hard drive is another type of hard drive but can be transported around with a user. These forms of backing up are very big and can come in 1 terabyte. A CD or compact disc is very hand-light circular disc. It can hold up to a maximum of 700 megabytes and can be very useful. A DVD or a digital video disc is very good as it can hold up to 4.7 gigabytes and have exactly the same dimensions as a CD. A tape drive is a storage device that uses a long strip of magnetic tape to store its data onto. There is also an increasing number of online backup options available, where data is stored on a remote internet server. A full backup is when the user wishes to back up all their files at once. This form of backing up is very effective but usually takes a very long time. To do a full backup, a user can use many different types of items to back up onto. An incremental backup is when the user has already done a full backup and therefore has backed up most of their work. An incremental backup is when the user needs to back up all the files and information that they have done since last time they backed up. This backup is usually a lot more effective than a full backup because it doesn't take as long and there is no way near big. Another way that we can describe an incremental backup is that it only backs up files created or changed since the last normal backup. It marks files as having been backed up. If you use a combination of normal and incremental backups, you will need to have the last normal backup set as well as incremental backup set in order to restore your data.